effortless 3D with React Fiber. The wow effect. This is the moment we are using a website and say, wow, this is great. It comes from the small things, a smooth transition, a micro interaction, some illustrations. Those small things create create magic. We feel that someone cares about our experience, and it builds trust. 3D is one of the fastest ways to create that wow effect. It's visual, it's interactive, and it immediately grabs attention. Even a simple 3D touch can make your product stand out. We have a lot of examples, from Next.js Conf website to the other Next.js Conf website to Apple iPhone, and even recent with their marketing website. A lot of people think you need to be a 3D specialist in order to create 3D experiences in the web. But 3D isn't just for experts. It's a creative tool that anyone can use. My name is Nir Tamir. I've been doing front-end for over a decade. You can find more about me at nirtamir.com or follow me on Twitter. We are going to use 3JS, which is a JavaScript library to creating 3D graphics in the browser. Most 3JS apps have the same core elements. First, we need to have a renderer that handles rendering your 3D scene in a browser using WebGL. Then, we have a scene, which is a container for our element. This is the stage and the space where all the 3D objects, light, and cameras live. Then we have a camera, which is the eyes of the viewer. It defines which part of 3D scene is visible and how it's projected onto the 2D screen. And then we have lights, so we won't have everything dark. And we have meshes, which are the 3D objects you actually see. Mesh is made of two parts, geometry, which is the shape, and material, which is like the skin. So geometry is like the shape. It defines the vertices, which are points in space, the faces, which are the triangles built from those points, and the shape, like cube, sphere, costume model. And material is the skin that wraps the geometry. It controls the color, the shininess, the transparency, texture maps, and how it reacts to light. Let's see what vanilla 3JS code looks like. First, we import all the strip from 3JS. Then we create a WebGL renderer. This creates a canvas element and handles all the low-level WebGL rendering. We set its size and append it to the DOM. Then we create a scene. We add a perspective camera, and we set it a position. Then we create a box geometry with height and width, and depth of 1, and mesh basic material with a blue color. And we create a cube mesh. Then we need to add the mesh to the scene, and render it using our camera. Notice how verbose this code is. Only to render a blue cube. So we can do better. And we will see how React Fiber simplifies this in a moment. React Fiber is a React renderer for 3JS, which means we use React reconciliation to manage your 3D scene. Instead of imperatively creating objects and adding them to the scene, you declare them how you want using JSX. It handles all the setup boilerplate and gives you the React component model for free. So we get prop, state, hooks, and JSX. We write the code just like we are using React code, but inside the 3JS world. Let's see it in action. So in this example, I import a canvas from React Fiber, and the canvas replaces all the setup code from the previous example, all the renderer, the scene, and the render loop. Then I created a mesh with a box geometry and a mesh matcap material in a color blue. And this is all the code that need to render this cube. Now, I also added orbit controls from React Ray, which is a utility library in the ecosystem that creates a lot of high-level components we can use. So orbit controls allow me to move the cube using the mouse. So we are moving the camera. We can zoom and we can zoom in and zoom out and move the object. Now, we can use different geometries, like I showed you before. So if we switch from box geometry to a sphere geometry, it will look like a ball. If we change it to a plane, it will look like a plane. Let's move it so it look like 2D. We can also use torus, which is like a donut, good for Hanukkah. And we also have a torus not geometry, which is this bagel. We can also change the materials easily. So we started with matcap material. We can use the tune material. We can use the normal material. And we can also use other materials, like a Lambert material. This material reacts to light. So if we'll take the light from the scene, it will look very dark. Actually, I can take both lights, and it will look very dark. And we can also use the standard material, which is very similar to Lambert material, but it has other properties like metalness. So if we will add it, we can have a different view. If I'm changing it to 1, it will look like this, and if I'm changing it to 3, it will look more shining. Each mesh has a position, scale, and rotation attributes, and we can change them. So we can change the X, Y, or Z positions. It's like a vector. So if we change the position from 0, 0, 0 to 1, 0, 0, it will move one unit in the X location. I also added the axis helper to help us look at which axis are we going with. So like RGB is X, Y, Z. Red is the X direction, green is the Y direction, goes up, and Z is the blue axis. So if we change the position in the X axis and Y axis, it will go a little bit higher. We can also change the scale only in the Y position, but also in all the positions. And we can also change the rotation. Rotation are using gradients like in mathematics, so we can rotate in 45 degrees by using matpi divided by 4. And for each geometry, we also have arcs, which is the arguments in the constructor of 3JS, so we can also change the height, width, and depth using those arguments. So because we are using React, we can also extract components and accept props. So in this example, I created a box component, and I set a position from the app component, and I created two box components. And inside the box, we can also have state. So I set a state value for is blue and is large. And when I click on the item, I toggle the box to be large or small. And when I hover it, using those events, I'm changing it to blue. And we can also animate elements using useFrame. This is a hook that React Fiber provides us, and it's very similar to request animation frame. It runs on every frame, so make sure not to run expensive computations inside. And it accepts two parameters, the state of the clock and the delta, which is the time that passed since the previous rendering. We can take the mesh, assign it a ref, and then rotate it in the X position with the delta. If we want to rotate it a little bit faster, we can rotate it by delta multiplied by 3. So we defined some basic elements that 3JS provide us, but what if we want something cooler than a box? So this is where we come into the custom models. We can download models from the internet, and the format is GLTF. We can use GLTF from website like Sketchfab, which has a lot of models, and render it inside our 3JS scene. So let's see an example. I download some models on my computer, I download the iPhone 16 model. Let's make it larger. And I render it into the screen using the GLTF-JSX. GLTF-JSX is a tool that parses the model and generates code with all the meshes, material, and hierarchies. So it provides me this code automatically. I use the GLTF-JSX playground. And we have the iPhone, and we can see the meshes inside. So all we need to do in order to import it in our code is to copy this code and paste it, and use the iPhone model with the model component. As you can see, it uses GLTF, and it expects the model to be served in the public directory. So this is how you render iPhone in your scene. Now, we can also add physics into our scene to make things look like in the real world. So the idea with physics is to add a physics library, and it handles all the physics world, and we have also the view world. So like in physics class, that we have the shapes with the forces that applies on them, we can also tell the physics world which forces are applied and which elements are we using. Let's see it in action. So here, I use the React Rapier, which is a physics library, and I created a physics provider from this library. And I have the mesh from the previous example, but I wrapped it in a rigid body with a collider of cuboid. So the physics library will refer it as a cube. I also added a cuboid collider from the physics library, React Rapier, to serve as a floor. And I set the debug, so we'll see how the physics library refers to those elements. If we refresh this example, we will see the cube falling because of the gravity to the ground. Now, we can create multiple components, like sphere and torus. And for sphere component, I will use the collider of ball, because it looks like a ball. If I use it like a cuboid, the ball will behave like a cube from physics perspective. And for more complex object, we are using tree mesh. Now, if you look at the ball, I made on click event handler that every time I click on the ball, it will jump a little bit. So I apply impulse in the y direction. This is how it jumps. So the key takeaways. We defined the core tree.js concept. We learn how React Fiber make it declarative with React components. We add some interactivity with events and state. We animate using useFrame, and we imported 3D models. And we also add physics with Rapier. So we covered a lot today. The best way to learn is by doing. I created a small project with a 3D model of myself, and using the same core elements in tree.js, I was able to create this playground that you are moving in the space. If you think about it, it's just the 3D elements that we defined before with some materials and a specific character physics. If you want to learn more about React Fiber, you can look at the documentation. They have a lot of examples with a code sandbox that you can look at it and just try it yourself. So I encourage you to go and build stuff. Create that wow effect. Or at least have some fun, like I did. Thank you very much. You can have the slides.